Thank you very much, Hassan. Can you hear me?
Yes, we can hear you.
That's great. So let me start sharing my presentation. I need to find a way to do it properly. And I must admit, I have not used this presentation sharing in Zoom, so I might
Ondan şu
be.
an share and maybe it's better if you have opened already some application, choose not the entire screen, but
Yes, just some application, but it don't have the same capabilities as Teams do. So you should see this presentation. Do you see it?
yes, we can see it.
Let me try to switch to slideshow mode. Is it visible normally?
Yes, we can see full screen.
Full screen slideshow. That's great. Sorry, please. For some reason it is automated. So, good day, colleagues. Thank you very much for staying with this room. I will start my presentation. It will be focused on, I think, more simpler topic than it was before, and also it will be rather code-oriented. I would like to talk about, I would say, not actual object-oriented patterns in Python. That's why I named my presentation Python Semi-Patterns. I think this is a collection of some templates I have found out during my engineering work in past years that might be useful, and I have found out that they are usually useful on practically any project where I participate as a backend engineer. And they help to write robust and maintainable Python code, at least from my perspective. So let's move on. First of all, a couple of thoughts about myself. I'm Evgenii. Actually, my official name is written like that, like it is here, but transliteration rule changes, so I can be written differently. I work here in EPAM for more than 9 years, practically 10 years without a couple of days. And all of my experience is in Python and data engineering. Right now, I'm chief software engineer in data officially. So a couple of facts, I'm AWS and Azure certified, mostly AWS, despite now I hold only one certification. I held more in the past. Databricks champion, so I specialize in data a lot, and I work recently a lot more with Spark and Databricks. And despite I'm Databricks champion, I still think that it is important to separate engineering from, promoting vendors. Vendors make promises, engineers keep the promises. So let's dig into the presentation. What patterns I would like to consider here, and I think they are useful. Basically, this is quite short list. First, I think this is something that is common across a lot of modern Python code bases, using data classes and using data classes by default. Second, sort of extension from the previous pattern, typeful configuration. Next, the ones that many people encounter when they start their Python journey and learn about something like meta classes, import-based plugin system. Next, application context and a bit about its relation to inversion of control and dependency injection principles. And next, I think very practical, for some reason, not very used in Python projects. Hopefully, this will be used more, context variables, context vars, instead of global variables. Disclaimer, I will talk about some third-party libraries here. You don't have to use any of them. And actually, I must say, I don't use some of them at all. At any of my projects, I have never used some of the libraries I would mention here as really good libraries. So they are just great examples of inspiration for your ideation, but you don't have to use them. Let's move. Data classes by default. This is something that I think is important to use. Many developers consider data classes to be useful, or at least intended to be used only for data transfer objects or data objects. But in reality, even if you look at the PEP introducing data classes itself, it will talk about providing this template data class functionality where you can create basically in a fast, streamlined manner your class with already defined init and other methods like equals and actually hash as well. And it will be typeful. You can also freeze the data class, etc. And this is the intended idea, not just create data transfer objects, but easy and easy to use and easy to maintain way of creating your classes. I think it is also very important to use this pattern because it somewhat helps you to enforce composability, composition over inheritance. One of the problems that I often encountered in all programming languages that support inheritance and in Python as well, especially given that Python supports multiple inheritance, it is that people overuse and abuse subclasses. Almost always there is little reason to subclass. It is practically almost always more beneficial to prefer composition and data classes. You have to add decorator, data class, or similar decorator to any of your classes when you create a data class. This is at least a way how you prevent over subclassing with data classes. Plus, there are some other limitations. Originally, I think data classes were created with others module. It actually supports more powerful inheritance patterns, but others is not completely adopted in the data classes. I would say library data classes module. Nowadays, I practically always recommend to use Pydantic, even if you don't have fast API, but you can introduce such library. It has a lot of great features, and I think Pydantic is a valuable addition. If you are using fast API or similar library that already uses Pydantic, just use Pydantic. So, small example with Pydantic. It has drop-in replacement for data class decorator. You can just use it. It will also apply validation from Pydantic. So if you are, let's say, reliant on flexible rules in data classes that don't require validation, you will have to disable it. But also it is good approach in most of the applications. It provides you not only with type safety on, type checking level when you run type checker similar to MyPy, but as well type safety or validation safety when you actually run your application. Of course, if you test substantially and your tests cover every class of your application. Nothing to say here except that you can provide description, and this will allow you better document your fields. Let's move on to the next slide. Basically, typeful configuration. Sorry for this bug. I'm not sure why it is non-capitalized typeful here, but still common problems that I have observed in many applications, and the extension of previous pattern data classes, it can be viewed as providing something like easy to be described configuration as a data class itself. The common problem that people store the configuration in a place separate from actual code. It can be solved by storing configuration, of course, with the code infrastructure as a code configuration as files that you version and update, but still there is little governance over configuration except conventions. Basically, you write your configuration in YAML or JSON file or store it in some server, but there is no validation that this string or this number of symbols is correct. With typed configuration, you enforce rules, how configuration should look like, what format it should have, what should be possible values for specific parameters. You can also describe composition of configuration, its structure, etc. Basically, you provide, of course, a rigid structure. It requires more rigorous description, especially if you are using code-based configuration. But luckily, in Python, you have, first of all, libraries that support it. You can easily implement it without these libraries, but it will be simpler to use something like Pydantic settings. You will gain capabilities like automatically checking types, including IDE support, plus some autocorrection, plus you will also have capability to simply import your configuration. Of course, you can do it the very same way with Python-based dictionary configuration, but you will lose typing capabilities of type checking in IDE straight from the trenches. And of course, if you are using something like Pydantic settings, you will still have capability to join your configuration with other configuration sources. And it is, I would think, better than using just argparse or a bit more even advanced modules like doc-opt. Maybe you are familiar with such configuration special solutions. They have some advantages on their own, but generally they were not designed to support typed configuration, and they are not as, I would say, opinionated as pydantic settings. You can also easily implement configuration profiles with this approach. What I mean is that you can create configuration or settings object class, and then ideally you do not subclass. You can also subclass, but you once again create instances, and for specific environment you're creating different instances with different settings. Generally, you have limited number of environments, so in practically every project you will see this configuration stored statically in the code base. Of course, it is updated, versioned, but now you can easily dispatch this configuration in your code, and you simply observe how it is being loaded. You control its loading. You can create simple proxy, for example, like here, lazy proxy object. Once again, you don't have to use this loading pattern and this lazy proxy, but it allows you to define your application settings as, of course, global variable. I already talked previously that global variables are not great, but for such solutions, they are okay, I think. And of course, you can improve slightly this pattern by not using global variables everywhere. After that, you can easily update your centralized place, environment settings, and app settings. And when you update configuration for specific environment, specific profile, specific context, you can then just access your configuration as real object with dot notation, and in the background, configuration will be loaded. You can basically modify this loading mechanism, add configuration from different sources. Generally, I have found YAML sources or .ini files, toml files also, they work the best. And YAML is generally safe approach, despite there are many critics of YAML format. I think it is absolutely fine to be used. Plus, if you are using pydantic settings, you are automatically providing capability to enhance your configuration with .env files, with environment variables, and there will be reasonable defaults. For example, that your configuration that you provide most explicitly, it will take precedence over the configuration that is provided more implicitly, like environment variables. So let's go further. And what I'm talking about in relation to pydantic, you can also enforce, for example, validation with pydantic when you create your settings. Here you can build validators, for example, unsafe passwords. Of course, you don't want to use such simple validation, but it is very possible to build sensible validators and also enhance capabilities to parse and to automatically check that your configuration in the file is correct before you actually even write any unit test. You simply write these validators, you simply write your settings configuration file, and test just instantiates configuration from the config file. That's it. Validation will happen, and you will have either success, no exception, or error will be thrown out. And of course, I like a lot of parsing capabilities from pydantic, especially date-time support, for example, because it is always a pain when you need date-time parsing and date-time and time delta support, and you don't have proper library to work with it. In Python nowadays, it is really good in comparison to what it was before. Plus, time zone support is significantly improved, but still, for example, ability to pass just time delta in ISO format is really nice. It really helped me on one of the projects I recently worked with. And also secrets, you simply pass secret string. Of course, it is not encrypted in memory. It is just reducting to avoid occasionally printing it to console when you log your configuration or when you print it as a variable. So this will be avoided when you are using this built-in extras from pydantic. Next, what I want to talk about. I would like to jump from previous, I would say, configuration to areas that I have observed on many projects. Practically every project I have worked with had this imports as plugin system in either explicit way or implicit way. What I mean, usually people observe this pattern, I would say, when they study metaclasses. They want to understand what is metaclass, and there is example that you can use metaclass to create a registry of something. For example, this is how it is done in SQL Alchemy or in other project. Your classes will be scanned, registered somewhere, will be discoverable, etc. And imports act as a natural way to provide this discoverability enablement and work of such plugin systems if you pair it with some tricks related to class instantiation. Because of course, as we know, Python will execute all top level lines on your module when it is imported, and classes as class objects will be instantiated. And during this instantiation, meta class can hook into the process and modify how it happens. Meta classes, as we know, is actually a playground for developers to create such interesting use cases that were later inspected by Python community and especially Python core developers themselves, and they provided more streamlined capabilities to have the very same functionality in a more constrained but much easier to use way. For example, init subclass emerged as a capability from the meta class usage. Init subclass allows to do the very same hooking into the class initialization when subclassing happens, and during the creation, first, of course, new method will be called, and then init will be called, and during init, you can simply, for example, populate registry of anything here, reader registry, like, let's say, CSV, JSON, Avro, whatever data format, if we are speaking about data project. I have seen it in many data projects, similar functionality. From my perspective, it is also important to avoid unnecessary mangling or hiding of details in such implementations, because basically you will end up with a lot of code that have these underscores, but there is not much advantage in real life. You will not gain anything practically if you use what you think is private. You simply mangle everything and then you write test and you can import your code in a test. But of course you can. And also what I think it is important to avoid from the beginning, non-Python based, non-import based plugin registration. It can be done. It is not hard to do, but you introduce more and more conventional approaches that require learning these conventions, basically knowing it by heart, but not by reflex, not naturally. And let's go further. Sorry, here it is. You basically use such plugins in a way that you can have some library functionality or some standard functionality that you just import, run, and it works if you implement and enable proper plugin. This plugin can be implemented by a different team, so they simply provide connector, for example, to some API, some integration, whatever. And you just use the standard functionality that you always use, that you are familiar with, but you are not concerned, of course, with plugin implementation. Here, basic example, just a function. Of course, as it is written in to-do, commonly it is configured with some not function-based approach, but method in a Fluent style builder, providing this example will be more complex, like you may think about Fluent builders for requests. If we are speaking about requests for more or less standardized, not REST, but let's say some alternative similar to GraphQL, whatever, where you provide settings, configuration, servers where you use in a Fluent dot notation. Here it is quite easy to pass parameters when you need to instantiate your reader class or any class of your plugin or your plugin itself using this Fluent builder. So your parameters will be stored after you use builder pattern in some dictionary, and then they will simply be passed to plugin that you would like to use. What are disadvantages of imports as a plugin system? First, you will have to have necessary modules on your Python path. Basically, you will have to install them and import them. Two moments here, installation. So of course you have to have them in requirements or any other way in somewhere your project know that you have to install them. Next, you have to import them actually. And this is important for both discovery and enablement. Discovery can be done in different manner. So you just have to know from where to import. So discovery can be decoupled basically, theoretically from importing, but importing is very tightly coupled with loading of plugin and enabling, because logically you don't have to be sort of enable plugin immediately as you load it. So you loading is having it accessible in your code, enabling, making it work when you run your code and you try to access plugin. Plus, using everything with type of configuration, typed approach, type safe, it allows you to write type safe code and also have easy to use auto completion of IDE, whatever, because basically these types, they provide a lot of context for even regular IntelliSense and especially for chatbot copilot based completion. But also when you try to modify something or if standard plugin system changes that you wrote, it will break a lot of stuff. So you can't easily change or you can't easily provide changes. I recommend if you would like still to use plugins, anything that you would like to implement standard functionality and then drop in, basically put building blocks without thinking how to modify standard functionality, to consider imports as a plugin system, because it is easy to use and very convenient way to use if you have small project. In small project where you have one basically repository or couple of repositories, it is manageable by the single team. You will never run into problems with this imports as plugin system. If you have multiple teams and multiple projects, especially products, then it is better not to use this approach. And of course, you can consider monorepository, and it is always a valuable possible solution. Also, please read, once again, sorry for this, I think it is import to PDF problem on my side, because the capitalization of some words should have been correct when I opened it in PowerPoint. So consider Stevedore package. Actually, it is not just simply package. It is the link here. You will see it is linked to very comprehensive documentation and story what actually plugin system is and how to work with plugin system, what to look for implementation of plugin system. Stevedore provides you with standard functionality to build such plugins for your own application. It is very comprehensive. I have never used it. It is implemented by OpenStack developers as a set of one of the Oslo packages. Maybe you have heard about Oslo. It is a set of modules. I recommend to look at any of them, but don't think that you have to use them. So let's move further on. Application context. I think this is more useful pattern that I have found being useful on practically every project that I have seen, yet people implicitly implemented practically always, but explicitly very rarely in Python. In Java world, everybody have seen Spring or Juice or anything like that, and they know that application context is part of such frameworks. It is usually combined with IOC or dependency injection container and a lot of other functionality. Actually, it don't have to provide you basically inversion of control capabilities. It is a place where you present your components in a single, let's say, module or observable way, so they can be placed there. You can easily manage them in this one place. Or, of course, in a couple of such contexts, if you have different profiles. Generally, it is not a great idea to have nested contexts based on my experience with everything that I have seen in Java. And especially, it is a really bad idea to load them dynamically. So application context, what I have seen, it is a standard just place that people use in the applications where they have a lot of components. I think it is good to structure many how can I say, objects, components, whatever in your solution in this way, because it allows you to basically materialize under the side what you have, what components you instantiate, what dependencies between them you have, and you will immediately see that some simple, allegedly simple places actually are very complex because there are a lot of components wired in together and connected in together. You will also see inefficiencies. Maybe some components are expensive to work with, expensive to create, and you don't cache them. Maybe you see that there are great inefficiencies in how you practically create some components and they are connection-based, session-based, etc. Something that you hold for a long time, but something that is expensive from performance or maybe even cost perspective to hold for a long time. So it is just sort of materialization of phantom configuration, phantom context. And I think it is important to consider, even if you don't find inversion of control container valuable in Python. Just start from such explicit context, single class, where you simply wire in your components, connect them together, and see how they can be used. Outside of this class, you simply grab them from this class. Ideally prefer instantiation over using class methods because once again, it is easy to use as a class method, but it will be additional decorator. And later on, you would like maybe to modify something. Modifying class methods, modifying more static content is always harder than modifying instance. Let's go further. Next step, basically inversion of control. IOC, as I already mentioned, it stands for inversion of control and dependency injection. If you, hopefully everybody here heard about this, I would say, patterns or development practices, basically dependency injection simply means that we pass dependencies to our classes, to our let's say dependents, instead of pulling them, creating them inside this dependence. The basic way to provide dependency injection is to perform creation of objects in some, usually centralized, even if it is not explicitly named context, maybe your main method, and then you pass dependency to your constructors when you create your objects, and you can run your application. Do I have enough time, Hassan? You enabled your video.
Yes, please. You have around 10 minutes and you can.
Okay. So yes, I don't have a lot of more slides. Basically, you may have seen, if you worked with Fast API, this DI support in Fast API. It is nicely done. It is not the most advanced I have seen, and definitely it supports, for example, only top-level methods. In this example, we can create IOC container easily. We can create even enhance it with type-based dispatch, with dispatching functionality. For example, you don't need to explicitly wire in your dependencies. Very common way to wire dependencies is provide them by type or name. And actually, if you think about it, in Python, we already have or will have soon such capability. Maybe you have heard about PEP that proposes keyword-based injection of variables by the variable name. Basically, you have your function, if you don't heard about it, and in function, you have keyword arguments. When you provide your keyword arguments outside of function in a namespace scope as variables, you simply run your function with keyword arguments. You write something like argument x equals, but your argument x exists also as a variable with same name argument x outside of the function. You do not write anything after equals, you simply write comma, and this is injection from namespace. Python will automatically look up, interpreter will look up namespace to inject this parameter implicitly into the function. Looks, I would say, too implicit for Python, and we know that implicits in this manner are quite, I would say, controversial in other languages, but it is still a way to provide dependencies, dispatch them by name. Next way, how to implement such IOC container. It is a bit bigger example, but still manageable. You can easily create a basic IOC container. I must say you don't have to use it. I'm usually not using it in most of my applications, even in larger ones, especially if you're speaking about data-oriented applications. Generally, we have very similar configuration or wiring in entry points of application, but we don't name it as IOC container. We simply have some wire entry points where we can create objects, where we can have access points, but using this IOC container explicitly, if you don't have any such structure in your application, may allow you to basically introduce this entry points for structure and maintainability of your project. So this is just a suggestion that if you don't have such well-defined structured entry points and container points in your application, to introduce them explicitly using this container way, you can use type annotations to dispatch. I'm not claiming that this is really usable in production code. It can be used, it can be enhanced, but I must say it is quite basic implementations that fit into screen into one slide. By no means I would say that you should use exactly this approach. And if you, sorry, if you are, by the way, I think I forgot to add link here. They will be in the references. If you are would like to use something like this IOC container in a more comprehensive way, consider not writing one on your own, but using standard libraries like injector or there is one very comprehensive dependency injector. If you do not use already libraries like Fast API or any other libraries that has its own conventions and its own way to structure application, consider using injector. This is really nice small library with similar functionality, works out of the box. Let's go further. Context vars, not global vars. Once again, I really see problems with capitalization. Some letters are not capital, and they are capital in my presentation. So sorry for this PDF export issue. This is part of standard library since Python 3.7 at least, and so some strange reason it is a part that is continuously marked in IDE as you have to install it, but you don't have. It is shipped with any CPython installation. It is actually typed. You can provide type annotation for your context var what it should hold, so it can be also nicely typed as well. What I see, a lot of data-oriented code often is untyped. It is, from my perspective, quite a limitation. That's why I recommend typing everywhere. And context vars, unlike basic global variables, by default, out of the box, they will be thread safe and async IO safe. Thread local variables will only be thread safe, not async IO safe. And actually, context vars are being used and were created originally as extension of async IO variables that should have been async IO safe, similar to thread safety of thread locals. They don't require global keyword to be modified. Of course, there is a price. There is a more complex API than with global variables, but it is also more comprehensive. You can set explicitly value of context var, and you can explicitly reset it back using token. And token is specific for a particular reset operation. So you reset it to exactly particular value that was before this token was generated. This token is unique for context variable that you are working with. And you can easily create nested contexts, for example, using such approach. I would say just in a couple of slides, I would recommend strongly against nested context. I recommend against any nested context unless you have a really good reason to nest the very same, exactly same context multiple times. Because if you think about it, it is basically extending context multiple times. And if you do it in several methods, you will think in any method that context is small, it is just one method, but actually you extend it multiple times. If you are doing expensive CPU operation, IO bound operation, and if you are doing some network calls, especially to resources that cost money, you will spend time, performance, and money. That's why I don't recommend to have nested contexts and use context vars like that. What I recommend, of course, ideally, if you are using really global variables that you will import in many places, name it properly, appropriately with all capital plus underscore separator. You can create such context dependent variable, and then you can use it for different, let's say, executions of your processing with different contexts. In particular, I have found it useful to even use it for global variables in situations when you have one main method, but later on you can run this main method maybe in tests in isolation from modifying the global variable. It looks like small advantage, but basically you just provide your modifier that will modify the context to this context dot run method. First, you will do copy context to create a separate instance of the original context, and when you run your main method inside modified context with, of course, modifier code, the context will be modified. Context var will have appropriate value, for example, only for specific test, for specific unit test. And inside this method, you will execute your code. And then outside of this method, the global context will be unmodified, unchanged, and freshly being usable for any other purpose without need to think about how to revert it back, reset it to original fresh state. So it allows you to basically split your context easily without the need to worry about original fresh state, remembering it. And it is thread safe, as it was mentioned, and async IO safe. So already works out of the box and very useful in situations when you would like to configure something So inside configuration will be customized, but outside you preserve the original state with relative ease. And you already have this .run method that basically was created for exactly this purpose, together with copy context. Let's go further. Don't overuse context variables. This is just my point of next recommendation. If you are starting to use context variables, you might think that you will pass some configuration, some not only configuration, but data through them, like you might do through global variables. Especially egregious example is to use queues or anything to pass data to tasks to parallelize your code, is given the advent of prefetching in Python. Next version will have proper, finally, parallel threads without kill, of course, optionally. And then people pass their data in queues or in lists or concurrent data structures, I would say concurrent lists, and they think that this is good. Almost always it is better to use data parallel way to implement your, let's say, splitting of processing, whatever it is, request, API work, data, mathematical execution, executing AI models, whatever. Do not use these concurrent primitives unless you have really strong reason to use them. If you can modify logic that interacts with the data, so this logic can be orchestrated outside without using of such queues to pass data to this logic. Only if you can't modify the logic or it is too expensive, too complex, you can use this appropriate communication primitives, basically concurrent or multi-threaded, or we have in Python multi-processing based primitives to communicate between process, threads, concurrent routines. And you will see in this example, just create data class in most of the situations, put in this data class appropriate configuration and data, and then you can simply run it with all packed together. It will perform processing. If you access thread local variables a lot of times, you will observe performance hit. They are really much slower. Anything that provides this safety is really much slower than just accessing local data. This is simply a rule. And extra tip, as I mentioned, free threading. It is going to be introduced in the upcoming Python version 3.15. Of course, experimental, but very likely it will be possible to use in default mode in some next versions. It is very tempting if you use threads to use locks to provide some safety, to use synchronized decorator. It is not standard in Python, but there are many libraries that are shipped with synchronized decorator. Half of them, I assume, use wrap the library that is the best resource on descriptors in Python. And basically, synchronized decorator will use inside recursive or reentrant lock. It is really easy to create very big critical section, very big context with such nested reentrant locks. And in my practice, I have seen it once. I have seen it actually working with Python on my first project when I wrote concurrent thread-based code, and using of reentrant locks led to extended critical sections that eventually was observed as deadlocks. And how it was solved, just removed error letter, and everything started to fail with exceptions, because these critical sections actually, they when you modify them back to single methods, you will see how big they really are, and you will find a way to only trim them down to the small places where they are really needed. It is more work, but I highly recommend you to avoid reentrant locks when you will, if you will write free-threaded code in Python with synchronization. These are two links I provided here. Basically, they are one and the same. First one is a short story, a long story short, and second one is long story in the even more words. Dave Buttonhoff, original writer of ran recursive mutex for Unix standard, when he basically needed to rewrite some parts of operating systems so it will work with threads. So he created recursive mutex to make it thread safe. And it should have been a hack for a couple of months. This hack lives for decades and is standard solution now. That's what I wanted to share with you as interesting story. Links and references to stuff that I have talked about during this presentation. First, pydantic and pydantic settings. If you don't use pydantic now, and if you have never used it, please consider reading this links, read the documentation of pydantic and evaluate advantages of using it. If you are using already libraries that uses pydantic, consider using pydantic more in your own code base if it is okay for you, because basically if it already bleeds in your code base and you are not getting benefits from pydantic, it's sort of you're potentially having leaving value on the table. Stevedore guide. I don't recommend to use Stevedore, even if you really need to use plugin system in your code. If you really know that you need it, just read it and think how you can implement minimal plugin system based on this guide that is suitable for your project. I have seen a project I have worked right now. I'm working right now even on the project where there is a plugin system incorporated in platform libraries, and none of them uses Stevedore. But there were multiple iterations to make this plugin as contributions from different teams work in platform libraries. There were multiple iterations to refine this way of working.
If you don't mind, can we fastly move on question part,
Yes.
because we also exceed David. I'm sorry
Oh,
for.
sorry. So basically, this is all. Please look at these links, and I am open to connecting with you. I am open to your questions. This presentation, by the way, was made with the help of other community from EPAM DataZen community. So you can see that this is the logo of DataZen, and this is all from my side. I'm open to your questions.
Thank you. In chat, I don't have, I didn't see any question, but I want to raise one question. You mentioned about configuration, typal configuration in your first pages. And at this, what I've seen, most likely data engineering task is data validation, etc., and who is dealing with the fast API and so on. Where like installing can take an advantage of PyData, not PyData, Pydantic advantages. But when it comes to, let's assume you don't deal with fast API, you don't deal with data validation task, you have just 20 different configuration, but you keep it as a YAML file or as a .ini file. Even in that case, would you recommend installing Pydantic and managing this configuration with Pydantic, or is it also using
consider
classes? Yeah.
I would think about it because how much of a hassle is to install Pydantic. If you are using YAML, you already use PyYAML, so you already use non-standard library. Of course, it is just one dependency. Pydantic will be another one dependency. If you are using such configuration, I would consider making it typeful, simply with data class. So typeful configuration, it requires additional effort, but first thing that people will observe with typeful configuration is that they should enforce proper types, they should enforce proper configuration keys, because often you simply have extra keys that have no meaning nowadays, or maybe you have made a mistake with some of the keys and you are using default one. Next step is to consider creating a configuration option, configuration field, anything that represents configuration atom, the value that you can document. You will see it basically in any configuration-based library like docopt, especially optparse.
Okay, got it. So yes, I guess it's clear now. Thank you so much, and I hope everyone enjoyed and learned a lot. For me, it was actually very useful, at least since I'm saying you're not.
Thanks a lot.
Don't have experience. Thank you so much. Thank you.